For most people, fat, particularly the kind that bulges under the skin, is a three-letter word that makes them cringe. It makes our arms and thighs jiggle. It lingers despite our torturous attempts to get rid of it. For decades, researchers have looked for ways to reduce our collective stores of fat because they seem to do more harm than good. Over 1 billion adults are either overweight or obese, and more than 150 million adults have type 2 diabetes, which is driven by obesity-associated insulin resistance. But in recent years, an interesting question has been sparked. Is all fat bad? In the late 2000s, several research groups discovered something that shattered the consensus about the absolute dangers of body fat. But before that, here is some background knowledge. Humans produce two types of fat tissue, white and brown. White fat is the result of storing excess calories as an energy reserve. In contrast, brown fat cells burn these stored calories with the help of mitochondria and generate heat. Newborn infants have high brown fat levels, which is needed for heat regulation and protection from hypothermia, since they have not yet developed the ability to shiver to maintain their body temperature. It was assumed that all brown fat disappears during childhood. In 2009, new findings in the New England Journal of Medicine confirmed the discovery of active brown fat cells in healthy adults. The consensus from the studies suggested an inverse correlation between BMI and brown adipose tissue activity, which suggests that it likely plays a significant role in the regulation of body weight. Suddenly, the promise of brown fat to combat obesity seemed like a holy grail. The idea was appealingly simple. If researchers could figure out how to incite the body to produce extra brown fat or somehow stimulate existing brown fat, a large number of calories would be converted into heat, reducing deposits of white fat in the process. Thus, targeting brown adipose tissue became viewed as an appealing way to treat or prevent obesity and its associated diseases. This is especially important since there are currently only 3 drugs approved by the Food and Drug Administration specifically for weight loss, all of which focus primarily on the reduction of energy intake and none of which have provided adequate long-term clinical efficacy. There are 2 general approaches that can be used to increase brown adipose tissue mass and activity: an in vivo pharmacological approach using small molecules and growth factors to stimulate fat growth, differentiation, and activation, or we could use an ex vivo approach where one would isolate progenitor cells from an individual by liposuction, then induce brown adipogenesis using appropriate growth factors and transplanting them back into the original donor for in vivo expansion. The underlying principle that makes the approaches alluring therapy options is that only gram amounts of fat are needed to have a meaningful metabolic impact. However, there are some difficulties posed. One challenge is whether increasing fat mass will translate to increased activated fat levels, which is required for weight loss to occur. Whether treatments with drugs that increase fat activity could be sustained or used for only defined periods of time need to be examined. Also, it is not clear to what extent there might be even further increases in energy intake to offset energy expenditure by activated fat in adults. Another potential concern is that activation of fats to levels that cause weight reduction may result in unhealthy levels of heat generation. Nevertheless, these new findings have invigorated interest in the function and physiological relevance of brown adipose tissue in better understanding the mechanisms to regulate body weight. Thus, it is a promising therapeutic target for combating obesity and related metabolic disorders. With tools for studying brown fat having improved, the understanding of brown fat is turning a corner, and experimenters have challenged previous pessimism about its ability to help people lose weight. As bizarre as it sounds, fat may become an important ally in the fight against obesity.